Good day, everyone. We are the group of Fitiza. With us, we have Colasio, Colmo, Tigon, Dubuze, Fitiza, Narag, Pasaylo, Semeliano, Sardinia, and Siray. We are gathered today to discuss our final performance task number 2. We have to create the following program with three main menus: Honey BCB, ATM Simulator, Data Collection. We have to make sure that the users will be allowed to rerun each of the menu, rerun the program from start, and lastly, exit the program. For Honey BCB, a program that prints the number 1 to 100, but Honey for primary numbers, BCB for the multiples of both 5 and 3, BC for the multiples of 3 only, B for the multiples of 5 only. For the ATM simulator, design and implement an ATM simulator that simulates the functions of a real ATM. The ATM will support PIN authentication, deposit, transfers, withdrawal, and balance inquiry. And lastly, for the data collection, this menu shall allow the developer to create a program that will implement the utilization of list, tuple, set, and dictionary data types. We have our speakers for the discussion and walkthrough of each code: HoneyBCB by Narag, ATM by Colmo, data collection by Colasio, discuss the concept used in implementing the solution by showing and discussing the source code, HoneyBCB by Fitiza, ATM by Joshua.
These are the functions that we use for our main menu. We define each code to its corresponding numbers, and we use if statement to define which codes are the users going to run. If menu is equals to 1, then honeybc function will run. Else if main menu is equals to 2, then ATM simulator code will run. If the main menu is equals to 3, then data collector will run. Else, if the main menu is equals to 0, then the code will end. For us to loop our code that every time users exit the chosen code, it will bring up back to the main menu. We use the exit function. If the function exit is equals to n, then the code will go back to main menu. While exit is equals to n, then there will be an infinite loop. If the exit function is equals to y, then the entire code will end. Now, let's go to BCB code. Here are the BCB code. First, we create or define a functions of the HANA BCB code using the diff function. Then, we define number is equals to 1 to put it as a first counting number. Next, we use the for loops function for x in range of 101. Why can't we write to 100 for each for the range? Print 1 to 100 inclusive integers by itself would print from 0 to 99. Perhaps better we write it as a range 1 to 101 and avoid adding the 1 so that what we will use for x in range 1 to 100. Then define prime number is equal to 0. Next, we use another loop for integers in range. We divide the integers by 2 and add 1 factors for us to define the integers is or are prime or not. Then we use statement if. Then we use if statement. If statement is used for discussions making operations. If the remainder of two integers is equal to 0, then we add 1 to our prime number. If the remainder of integers that are divided by both 3 and 5 and both are equal to 0, then we print BCB. Else if the remainder of x and 3 is equal to 0 and only divisible by 3, then we print BC. As if the remainder of x and 5 is equal to 0 and only divisible by 5, then we print BC. I mean. Else if the prime is equal to 0, then we print honey. Else, if the integers are false in all the if statement, then we print x. If the HBV exit is equals to n, then the code will go back to main menu. For the discussion of ATM simulator code, let us hear it from Mr. Deacon.
Thank you very much, Mr. Jolian. So what we're going to first do here is we're going to define ATM simulator, and then it will print welcome to For Your Bank because that's what most banks do. They always have welcome. And then we're going to also define num as equal to false. And we're going to provide here a while loop that num is equal to false, then pin is equal to string input, then enter pin, so that the user will enter their pin, and it should be 6 digits because that's what according to the instruction. So if pin that is digit is equal to false, then it will print error that pin should only have numbers because there is no pin in the bank that has all letters, so it should only have numbers. Then we'll continue. Else if the length of pin is not equal to 6, then it will print error pin should have 6 digits. And then we'll continue. So the num is then equal to true. Then we proceed to the checking or verification of the number or the pin. So while pin is not equal to check number, or that's the name that we provided for the checking of the pin, then check is equal to string input, re-enter the pin. So if check is not equal to pin, then this will then provide another set of if statements and elif statements. So if check that is digit is equal to false, then they will print error. Pin should only have numbers again because maybe the user will provide again letters. So in order to uh, exclude that, we should make another statement again that pin should only have numbers to clarify that pin should only have numbers. Then we're going to continue to elif statement. Elif length check not equal to 6. It's like the same as what we have done above. Like yes, it will still go error. Pin should have only have 6 digits. Then we'll continue. And if checking of the verification of pin is not really true, then it will check and it will print sorry wrong pin. Try again. If check is equal to pin, on the other hand, then we will print verification successful, for they have verified the pin successfully. Then we'll go to accounts in order to be, we're going to go create a dictionary, which is accounts. So the accounts is equal to 1. Then we will provide another bracket, which is account. Then account is to savings, comma, balance is to 0. Because the user will have 0 balance because it doesn't happen magically. So we're going to provide the balance as 0, followed by 2, account current, then comma, balance 0. So if the user wanted to quit, then we provide here quit ATM is equal to false. We'll provide another loop, which is while quit ATM is equal to false, then print the following options, which is 1, balance inquiry, 2, withdrawal, 3, deposit, 4, transfer, and 0 is to exit ATM. So we're going to provide another value, which is tran, which stands for transaction. Tran is equal to string input, which is select your transaction. So what we want to do here is we want the user to select their transaction. So if tran is equal to 0, then of course the user will exit. We want to exit the program. So we're going to provide there a break. Or else if trans is equal to 1 and tran is equal to 2, 3, 4 respectively, then print is invalid menu input. Then we will continue with the program. So after that, we're going to go to another page, which is the accounts, and there are 2 accounts. So what we're going to do here is print. We're going to print savings and current. so that the user will also have options. So there's 1 for savings, 2 for current, and 3 for back. We're going to provide another value, which is account, or which stands for ACCT, is equal to string input, select your account, parentheses, parentheses. Okay, so after that, if account is equal to 3, then continue, because it's going to look back to where it started. Else, if account is not equal to 1 and account is not equal to 2, then it will say invalid account, because those are the only options provided for the user: 1, savings, and 2, and current. Okay, so we're going to continue after that. Then we're going to provide another value, which is balance is equal to accounts, followed by a bracket, account, and going to balance, which will link to our dictionary from the ones that we have provided in the accounts dictionary. So account type, which stands for ACCT underscore type, is equal to accounts, account, then account, ACC. So if transaction is equal to 1, then print your balance at account plus account type plus is plus string balance. Then if trans is equal to 2, then amount, we're going to put another value here. Amount is equal to string input, enter amount to withdraw from the account type, which the user selected, account, followed by string of account, which is account. Then after that, we're going to provide another statement, if statement. If amount dot is digit, then amount is equal to integer, which is parenthesis by amount. So if balance, we will provide on here another statement. If balance is less than amount, then print not enough balance. Else, if not balance not is less than amount, or else balance is not equal to amount, then print transaction successful. Okay, so going back to the if statement of the amount that is digit, then we're going to also provide an else for it. So if amount that is digit is not true, then we're going to print invalid amount. Next, for if transaction is equal to 3, then amount is equal to string. Well, we actually provide another value, which is amount, AMNT again. AMNT is equal to string input and the amount to deposit in the account type, which is savings or current account. So if amount is digit, then amount is equal integer. Actually, it's still the same as you're withdrawing, but we didn't provide here. We didn't provide here balance is less than amount, because we're not going to withdraw from the account. We're going to deposit it. All right. So balance plus equals amount. We're going to add from amount, we're going to add this certain amount to the balance. So the user will be able to incorporate any amount he or she wants to the balance, which is 0 at the present, or earlier. Well, we still remember in the dictionary that we had, so the balance is equal to 0. But if you're going to deposit, if the user is going to deposit, then the balance will be added by the amount that the user inputted. So we're going to print afterwards transaction successful. Else, if trans is not equal to 3, then print invalid amount. So if trans is equal to 4, then we're going to transfer. We at first we created a value, which is 2TO is equal to quotation marks. All right, in order to represent the number that we're going to transfer from or transfer to. All right, so if ACCT account is equal to 1, then the 2 is equal to 2. All right, 2 number. Then else if account is equal to 2, then the 2 that we created will be equal to 1. All right, so the accounts that we followed by accounts bracket ACCT bracket balance. We put inside the quotation mark, and it will be equal to balance. So afterwards, after having a transaction for the 4 options that the user had, we provided here a value which is ATM underscore exit, which will be equal to string input, and we will provide him or her with a statement, would you like to exit the ATM, so that the user will be able to uh, choose whether to exit the ATM or not, so that the loop will not go on forever. So we provide here an answer with yes or no that we're going to print afterwards. If the user is already going to exit the ATM, then we're going to print ATM simulator is exiting. So that's it for the ATM simulator. Going on to Narag.
So thank you, Mr. Digan. So next is the HoneyBee code is embedded in the main program in this program. So which is located in the primary function presented by the Python language function called main. Loops are iteration and logical arguments such as if-then statements are used in the method. A declaration of a list in a specified set of ranges between 1 and 101 is also available. The programmer used the end range of 101 since the show count is decreased by 1, resulting in a range of 1 to 100. The only operator used is modulo, which shows whether the equalization is 0 or not. So in this program, the concepts are loops and logical statements with modules, modules integers, and formatting the result to integers.
Next po the ATM simulator. While loop, logical statements, arithmetic operands, encoding and error handling, which is used to serve as an exception and loop back to the previous question, are outlined in the ATM simulator, starting with the while loop. This code will assume that the assertion is true and will return false if the argument does not match the logical statements reflect the method handling in the program's middle stage and the opinions designed to act as operands. Error handling is an excellent option to prevent any user errors in operating the software. As a result, the program will present an error message rather than an actual error that will cause the program to start. Thank you.
The data collector's idea is directly based on modifying the list following user feedback. It's essentially a data gathering application that saves the information in RAM, a temporary storage area. Many of the concepts must be considered in all of the systems have been met. These programs have truly exploited the Python's language principle in applying instruction sets to run themselves, which the developer or programmer implements. The creator also provided several arguments and logical instructions that the compiler must comprehend.